Welcome Year 9 students. We're looking at exercise 15C. These are the questions that I've set you today. I will attempt to do all of them, see if I can make a reasonably short video on that. So question number 3, we have a reflection in the x-axis. So that means that this is my reflection line all along here. Hope you can see that. Maybe I'll use a slightly bigger pen. This might make it easier. Yep, so I'm reflecting across the x-axis, the blue line here, roughly. Okay, now I've got a line L which joins 4, 2. So if I go across 4 and up 2, I've got that point there. And I also have a line -3, -1. So I go back 3 from the origin and down 1. So that is my line. Now, if I join these up, I'll see if I can do this with this stupid thing here. Yeah, it's not very cool. I'll just have to do it freehand. This tool is not very good. So I'll just draw it freehand and see where we come to with that. Not too bad at all. Okay, so that's my line L, and I'm going to reflect the line L. So this is part B. Draw ML by reflecting your line. So all that we need to do here is I'm going to look at first at this point at 4, 2, and I'm going to reflect it across the x-axis. So I go, well, perpendicularly, so 90-degree angle to the line of reflection, and you can see that I've gone up 2, so I need to go down 2 on the other side. So that is going to be there. Now I look at my second point over here, go perpendicularly, or 90-degree to the angle to the line that it's reflecting across, and you can see it's 1 there, so I'm going to have it up 1 here. And then if I just join those 2 points together, I'll try and draw it as accurately as I can. Oh gee, what a debacle. I can't do that very easily, but you get the general idea. That would be my reflection. Okay, so that is our first example. Let's see what we can do with this next one. I'll just get rid of this. Okay. So, in part 4, we're trying to draw a reflection in the line x equals 2. Okay, so my first step is to find where x equals 2, and that is this line that I'm drawing here. So that is where x is equal to 2. So that is my mirror. That is my mirror line in this particular case. Okay. And then I've got to draw a triangle, and the points are -1, -1. So I go back 1, down 1. That's my first point there. And then I also have the back 2 and up 2. So -2, 2, I think. -2, 2. And then I have a -3. 1, so that's my third point is there, and if I just join them up I should have my triangle. It's a lot harder on the computer than elsewhere, so that's looking pretty bad. I actually can't deal with that. Okay, there we go, roughly like that. Okay, now I'm going to reflect it on across. I'm going to draw RJ. So you'll notice this kind of terminology here, RJ. Well, J is the original triangle, so RJ means apply the reflection across the line to it. Okay, so again, we'll come perpendicularly to it. So let's look at this line here, this point here, this vertex. You can see that it is 4 points, or 4 away from the reflection line, so I'm going to go out 4 on the other side of the reflection line, and that point will be there. This point here you can see is only 3 away, so I'm only going to go 3 away on the other side of the line. And 1, 2, 3, 4, 5, the other one is 5 away, so I'm going to go 5 away, and that will bring me to out here. Right, and I just join this all up. And this would be RJ. There we go, it's a little bit better. RJ. Okay. Now, the last point that they get you to do is they want you to do R2J. Now, R2J means you apply the reflection twice. So, the first time, you can see that it takes us over to here. But if we apply the same reflection again, then it will take us back to this one again. So, R2J is equal to actually J. So, it's the pink. It'll be equal to that pink triangle. Okay, so that's that one done. Let's move on. Clear all this nonsense. Pulse back in here. Number 5. Oh man, this one's a big long one. Okay. So let's chuck in some points here. We've got a triangle with vertices 3, 1. So 3, 1 is here. And we've got a point at 2, 1. Here. And 2, 3. So nice little right angle triangle here. Perfect. Okay. And we've got R. So this is R. R equals reflection across x equals -1. Okay. So we'll do that. -1. I'll just pop that on here. That would be this line here. Roughly. You can see I've not been too accurate there, but you get the general idea. And then we could have N. And that's another reflection. Reflection, and it's this time across the line x equals to 4. So that would be here. Now, I hope I don't run out of room on this coordinate axis here, so this could be a problem, but I'll give you the general idea. Okay. First of all, we've got to do RT. So, RT. Well, I think this is T here. So we've got to apply the reflection across the x equals -1 to it, because that's R. So we're coming at it this way. You can see that that's 3 away, so we're going to be 3 away on the other side, so I think that should be there. This one is also 3 away, so this will be 3 away. And this one here is 4 away, so it will be out here. Now I'll just join that up. And you can just do a quick check. 1, 2, 3, 4. Looking good. Okay, so that's RT. That's part B. And then let's do part C. Now we're going to do NT. So now I'm reflecting across the N reflection, which is at x equals to 4. So I'm going this way, 1 that way, perpendicularly, 1 this way. So I've got that point there. Now I'm going to look at this one here. That's 2 away from it. So I'm going to go 2 away on the other side. So it should be there. This point here is 2 away. So I'm going to go 2 away there. And I should get something that looks like this. There we go. Okay. The next one I'm going to do is RNT. Okay, now we already have NT. Remember, that's the brown one. So now, since I've already got NT, I just need to reflect NT with R. Now, where is R? R is this blue line here. So I'm going to take the brown triangle and reflect it across the blue line. So you can see if I start here and go 1, 2, 3, 4, 5, 6, I've got to go 6 on the other side. So 1, 2, 3, 4, 5, 6. I think that point is going to be there. And since the point next to it, this one, is 1 further away, I can pop that 1 further away on the other side of the line. And I know that this point here is 2 up from that point, so I'm just going to go 2 up from that point, and that would be my reflection. And now, Part E. Let's try another color again. We'll do this one. E, right. Now for E, we are drawing nRT by reflecting RT. So we're going to take the blue triangle and then we're going to reflect it across N, which is the purple one. Now this is where I think we've got some problems, because if we count from here, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I can't go 8 this way because it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it'll be out here somewhere. Okay, and so it'll end up being like out here, and we can't do that one. I'm sorry. So your paper won't be able to do it. Okay. The last one is what maps RNT onto NRT. So that's how do we get from this red one to this purple one. And it's a bit hard for you to see because we've run out of room. But if I just draw some extra squares on here, like this, it might help a little bit. Okay, so this would be 11, this would be 12, this would be 13. Okay, so you can see that it's just a translation. So this would be, whoops, this would be F. Translation, because we're just sliding it along. And you can see that we've slid this point along from -8 all the way, where is it now? Over to 12. So it looks to me to be a translation of 20, 0. In other words, we've slid along 20 on the x-axis to the right, but we haven't moved up or down at all. So that would be, from my look at things, that should be what it is. Okay. Let's move on. That took a little longer than I was expecting. Get this out of the way. Get rid of all of that. Okay, moving on to 11. Okay, to solve 11, we can plot the points. So we've got a reflection that maps 5, 2 to 5, 2. So that sounds interesting. This brings up an important point. So 5, 2 to 5, 2. And I'm just going to do the left-hand coordinates first. So I've got 5, 2 to 5 becomes 5, 2. 2, 5 becomes something else, and 0, 0. So let's just say that this is mapping our first triangle. And it looks approximately like this. Now, this point here at 5, 2 stays on that point when we reflect it, which tells you something. That means that this point must be on the mirror line. Then we know that 2, 5, which is this point here, after it's reflected becomes -2, oh, sorry, 2, -1. So we've now got this point here. Okay. And then this point here becomes 0,4. So there. So we now have this triangle here. So where is the mirror line? Well, the key point is that we know that this is on the mirror line because it stays in the same place. Only something that's on a mirror line will stay in the same place after it's reflected. Now, it looks to me that our mirror line is going to be along here. That will mean that our 5, 2 point is on the mirror line, and we can just check. This point here ended up down here. Let's go down to the mirror line. 1, 2, 3, yes. 1, 2, 3, tick. Let's try this one. 1, 2, 1, 2, tick. So our mirror line, so we'd write for this one, mirror line at y equals 2, because our point is at y equals 2. That line is along y equals 2. Okay, that's number 11. That was nice and easy. Let's see if we can nail this last one quickly. Okay, the next one is number 12. No, I think I'll skip number 12 and let you guys try that one on your own. It uses similar logic to what we did in the previous question, the question 5. You're going to do a couple of reflections and then see how you get, what translation you do to get to from the original to the final image. So have a go at that one and see how you go. Alright team, good luck with all of this.